Hi class, in this section we're going to be looking at the behavior of functions as they approach a specific x value. Now, before we talk about the actual formulas or definitions, here's the idea. You're always looking at what is the function doing for a specific x value, and your basic answers are going to be your y values. So for example, if we're investigating what does the function do at x is equal to -2, your y values are going to be around 2.5. Same idea as x approaches 1. In this case, technically here we have a, let me use a different color. We have a break on the graph. As x approaches, as your function and x approaches 1 from the left, your y values are going to approach -1. But on the right hand side, from the positive values, your function actually approaches 1. So what limits refer to is the behavior of a function, and in this case we're looking for y values as x approaches a specific given value. Now we're looking for the following definition. We're mainly interested in limits that exist as you're approaching a function from the left or you're approaching a function from the right. So when both of these agree, then we typically say that your limit is defined. So you have to have an agreement on the function approaching a specific y value from the left and the right for the limit to be defined. If these two do not agree, then we typically say that the limit does not exist. Now, let's take a look at a couple of examples. And in this case, for the problem A, they're asking for this function as the limit approaches 1. Now, notice that this is your 1. In this case, on the left and on the right, you're approaching the values of 2. So for this one, we would simply say this is equal to 2. If they wanted a justification, then let me put it on with green. We would basically say that the limit as x approaches 1 from the negatives of f of x is equal to 2. And this is also equal to the limit as x approaches 1 from the positive side of the function. So meaning on the left with the negatives and on the positive, it's going to be approaching the same value, and in this case is 2. The only problem that we could have is if your function is basically not continuous, like here at 4, and your y values don't actually agree coming from the right or the left. Now let's take a look at problem B. This one's asking for x is equal to 2. The limit at 2, it's approaching 3. In this case, let me just write it as this is equal to 3. And if they wanted a justification, we could simply say that, well, coming from the positives and the negatives, your function at the x value of 2, it's approaching the y value of 3. So let me just write it out with quotation marks. This is the limit as x approaches 2 from the negatives of f of x is equal to 3, which is equal to the limit as x approaches 2 from the positives of f of x. So if they wanted a justification, we're basically saying that the limit on the left and on the right, or coming from the negatives and the positives, happens to agree on a y value. Let's take a look at C, and now it's asking for x approaches 3. Now, as x approaches 3, your y values get infinitely close to 1. So in this case, the limit is simply 1. And let me take a look. In this case, as the function approaches 3, which is 3 here, your y values on both directions are approaching 1. Once again, if they want a justification, we would simply write on the side that the limit as x approaches 3 of f of x is equal to 1, which is equal to the limit, actually this is from the negatives, as x approaches 3 from the positives of f of x, meaning that on both directions your limits agree. Now, let's take a look at, in this case, D. And D here has a problem, and here's the problem. As your function approaches 4, on the left you're approaching 2, and on the right hand side you're approaching 3. So here you don't have an agreement on your y values coming from both directions. So we would simply say that at this point it does not exist. Let me write it out. This is supposed to be D. I'll fix it on the handout. So in this case, does not exist. If they wanted a justification, most likely they're going to want a justification on this one. We would simply say that, and let me use green. Does the limit as x approaches 4 from the negatives of f of x, and coming from the negative side, or from the left, we would say that this is 2, and this is not equal to the limit as x approaches 4 from the positive side. On the positive side, or on the right, technically the function is approaching 3. Meaning that for the limit to exist, you need to have that the function is getting infinitely close to a specific y value. Here at x is equal to 4, well, there's a jump on the graph, and technically your limits don't agree. So this basic definition does not satisfy for the limit to exist. That's actually it for problem 1. Let me quickly talk about problem 2. Problem 2 is really short. So some of the problems that you're going to be given, you'll be given a function, or you may have to graph it. So problem 2, if you were to graph it on your own, actually has a minor problem. And this is because you can see the sketch here. This is provided by Desmos, but notice that at x is equal to 1, your actual graph, it's supposed to have an actual hole. The software, in order for it to display the hole on the graph, meaning your function here, it's not defined of 1 because this ratio would be undefined. The only problem is that the actual software, in order for you to see it, you have to zoom in almost to and click on the actual x value. If you zoom in, this is what you would see. So you would actually see a hole on the graph. On the good news, coming from the left and the right, you're approaching a y value of 3. So on this particular one, we would simply say that the limit as x approaches 1 of 2x squared minus x minus 1 over x minus 1 happens to be the values of 3. All they want us to do on this one is basically view the picture from the picture, or they may ask you to graph it and evaluate the limit. And then you can see that, well, on both directions, your function is approaching 3. The calculator and also the actual software like Desmos is not gonna actually display any removable discontinuities or any holes on the graph. That's actually it for problem 2.